Hi guys, this is Faizan and welcome to this session on competitive programming for beginners by Great Learning. So before we start, can you guys just quickly confirm if I'm audible or not? Just quickly write in the chat section. In the meanwhile, while we wait for others to join, I hope you guys are safe and you are following the guidelines. Maybe guidelines will be different from maybe state to state, but the problem still remains, right? You have to be safe and you are, you are abiding by the rules and regulations, okay? So personally, it has been a few tough weeks for me. So I hope you guys are safe, okay? So yeah, cool. So I can see, yes, we can hear you. Okay, cool, guys. Cool. So before we start, can you guys quickly write how many questions did you solve from last week to this week? So on Lead Code or maybe on Geeks for Geeks, quickly write in the chat. So how many easy questions or hard or how many questions did you solve? You are not audible. Am I not audible, guys? Okay, Mohammed. Is it same for all the other guys? Am I audible or not? This is my first session. No problem, Mayank, Muyuk. No problem. You just okay. Yeah, I am a bit down today. So yeah. So okay. I will try to speak loudly as loudly as I can. Okay. So great. So you guys can hear me, right? Cool. Cool, guys. So quickly, just quickly write how many questions did you solve? Great, great, great. So, okay, cool, guys, cool. So, first session, no problem. The guys with first session will understand this session, obviously. So, there is an independency of from session to session. So, but it is highly, it will be highly beneficial for you guys to check all the sessions, right? That all the this is part 7, so we have already done 6 parts, okay? So you guys can quickly check them. So I cannot see, okay, 4. Quickly, guys, quickly. We don't have that much time. So quickly, just write a 0. Maybe if you haven't started it yet, it's okay. So we will, okay, great, 8, great. So now let's get started with this session. So today's session is again about hash tables, hash sets, and as I told you 2 sessions before, right? So we are going to solve some hard problems. I mean, when I say hard problems, I mean that we are going to use the concepts of 2 easy problems. Okay, so 2 easy problems make a medium level problem. Then 2 medium level problems or two or three medium level problems make a hard problem. Okay, so now today we are going to see some medium level problems and which have been asked in Amazon, Facebook, Google. So why we are focusing on these companies, I mean to say, these, why are we trying to solve questions based on these companies? Because rest of the companies which are having less packages or which do not offer that much package, so they follow the same pattern. They don't build their own questions, they just copy paste the same thing. Okay, moreover, okay, so now let's get started. Okay, Surbi says first. Okay, no problem, so let's get started. Okay, so today we are going to focus on medium level problems. Okay, and we will include heaps with it. We will also see how we can implement hashing and heap. Okay, so now let's see our first question. So this is the most common question. It is asked in Amazon multiple number of times, Facebook also, Google also, and rest small companies, they usually take this in the face-to-face interview or in the coding interview. Okay, so let's get started. So now this is the first question. Triplet sum equal to k. Sorry. So this is a triplet sum. So you have to find, for example, if you see the input, right, 0 2 5 4 5 1 5. So if you see the k is given, so this k can be 0, this can be 10, this can be anything. Okay, you have to find the triplet with sum equal to k. Right now we have to find the triplet. What do you mean by triplet? There have to be, you have to pick 3 elements. Okay, it can be 0 5 5. Okay, so you have to pick that element and you have to sum it up, and it should sum up to 10. If that triplet is present in your array, then you just have to print your output should be true, else it should be false if that is not present. Okay, so the question is clear, right, guys? So quickly write yes, Yes or no? Yes or no? Yes, Aman says 3 loops. Okay, Aman. So this was asked in Amazon and Facebook. Do you think if you give this approach of solving 3 loops, or you're solving your problem using 3 loops, will you get selected? Obviously not. Okay. So now let's see. Okay, great. Now let's see the first approach, as Aman rightly said. Okay, so the first approach is of takes the or time complexity of big O of n cube. Okay, so why n cube? If you see this p, we are trying to find the triplet. Okay, so now if you see, if we go back to this array, so this 0 will be compared with all the elements. Okay, for 0 we will check 2. For this is the first for loop. Okay, this is the outer for loop. Then we have the inner for loop which works on I plus 1, that is 2, and then this 2 will work on j plus 1. This again the for loop starts, and now it will check for 5 4 5 1 5. Okay, so if you see, if you observe these loops carefully, why I'm writing array of ARR of -2? Why? Yes, Aman. The important thing is time complexity. Yes. Just to focus which programming language we are focusing on. So, Mayuk, so the programming language we are focusing on is right now it's Java, but you can easily implement it any language that you are comfortable in. Okay, if you are in second year or first year, maybe you can switch to switch language. But if you are in third year or fourth year, where switching doesn't make any sense, you should focus on coding rather than implementing it in a new language. Okay, I highly suggest you that if you are in the third year or fourth year, so you just focus on coding. Okay, first second already there. Okay, so if you see why I am doing this thing, because we are comparing, you see, this will array dot length -1. So we are comparing one element with the rest of the two. So these two shouldn't be included. Okay, so that's why -2. So this will obviously go for n. It will go for n-2 actually, and it will go for n-1, and it will go for n. So when we multiply these things, the time complexity will come into picture, and that should be of order of n cube. So obviously now if you see, so we are comparing, if you see this problem, so 0, 2 and 5. This will be the pointers. There will be the pointers, and when we add up them, it will become 7. So obviously it is not 10. Then we move along. For what will be the next? It will be again 0, 2 and 4. Again it won't be, right? This 0 and 2 are fixed for now. Okay, we are only changing the kth loop. So it will go from 5 4 3 2 1, and once if we found that element in here, we will return true. Okay, that's it. So we will return true. Else if we have exhausted this condition, for this loop is also exhausted, this loop is also exhausted, and this loop is also exhausted, then that means that we are certain that there is no pair or there is no triplet with sum 0. Okay, so great. Now what we do, we will just return false. That's it. Okay, so this is the first approach. Okay, obviously the interviewer won't be satisfied with this problem, right? So can you think of any other problem, any other solution that would help us? So there are 2 more solutions that depends on obviously on the interviewer what he asks. So I am going to show you both the solutions. Okay, so both the solutions will be there. So obviously it depends on the interviewer if he is satisfied with you using some extra, and I need you guys to listen and try to think more intuitively and listen carefully. Okay, so now let's see the second approach. Okay, so let's suppose that we are not sorting this thing. Okay, we are not using this thing, that's why I have marked it in yellow. Okay, so now what we have the array as, let me show you this array again, 0 2 5 4 5 1 5, 0 2 5 0 2 5 4 5 1 5. Okay, this is the array, right? Okay, cool, Aman. So now you see we have reduced the time complexity from n cube to n square, and we are not using any extra space. Obviously we are not using any extra space, but the thing that we are using, let's forget about this thing right now. Okay, so now what we are doing, we are looping around again. Okay, and we are our I pointer is here on 0, and we are using two more pointers. Okay, one will start from here, that is the left, and then another is here, right? So these two pointers we are using. Okay, the two pointer approach. Okay, kind of a. Now obviously we know that two pointer won't work, right? We have done a session on that as well, right? We know that that won't work. Okay, why? Because for that two pointers to work, we need a sorted array. So let's suppose some of us are new, so we don't know what a two pointer is. So that's why we will just forget about this, why we sorted this thing for now. Okay, so now what we are doing, so our L is here, the left pointer, and the right pointer is here. Now what we are doing, we are just adding up. So obviously we have three elements, right? The triplet, and we are checking if that is equal to k. That's what we are doing here, right? Now what if this sum comes up to be, I mean to say the sum is less than, I mean to say the sum was 10, right? So 7 is less than. So should we move this pointer or should we move this pointer? That is not, I mean to say, if we won't sort it, we won't be able to find out how, to which direction we should we move. But if we have a sorted array, then things will be easier. Obviously, if something is here, so obviously we don't focus on something that is already present here, right? 0, -1, maybe -2. We won't focus on that because we know if this sum is less than the current value, obviously if we move in this direction, that will also be less than, right? This array should be sorted, so we can focus on these elements. Obviously we will get our answer in this part. So that's why when we sort this array, let's suppose we sort this array 0, 2, 0, 1, 2, and then we have 4, and then we have 5, 5, and 5. Okay, we have 3 5s. Okay, cool. So now what we have I pointer here, our L is here, and our R is here. So now once we have sorted this array, now this thing is clear, right? Why we have done sorting. Okay, again we need to compare left and right. Okay, yes, exactly. So now once we have these pointers, now it's easy for us to move in either in this direction or either in this direction. So now let's see. So obviously this sum will come up with 6, come up to 6, right? 0, 1, and 5 will come up to 6. Obviously it is less than 10, so we won't focus on this and this, and we will move our pointer, that we increment our pointer, and our left pointer will be here. Okay, cool guys. So now obviously again this is what 2 plus 5 is 7. 7 is again less than 10, so we will remove this thing, not removing, but we will point our pointer to here. Okay, now this thing is clear, right guys? So similarly, if the case would have been that we are trying to find out something that is let's suppose that 7 is greater than 5, and we are trying to find the 5 sum, obviously we won't focus on this because right now that elements will be greater than that. Okay, so now is this solution clear? And we are doing it in 2 passes. Okay, what do you mean by that thing? So the first pass will be this thing, right? We are sorting it, right? So it will take n log n time complexity, right? Or in the worst case, so can you guys quickly tell me, this is kind of a, okay, so okay, great, thank you. So great. So if you guys can quickly tell me, when we apply arrays.sort, okay, I want an answer from everyone. When we apply arrays.sort, which sorting algorithm which sorting algorithm is applied? So is it sir, we need to use triplet, but you are telling 5 plus 2 only. So okay, so what Uday, because 0th is also present there, na? So we are having 3 pointers, right? 0, that I pointer is starting from 0 to n. Okay, this loop will iterate. Okay, this loop, that 0, it will be first present on 0, then it will be 1, then it will be 2, then it will be 3, then it will be 4. So that's why. So that thing has been taken care by this ith loop, and the 2 triplet that we are forming is from I, L, and J, left pointer and our right pointer, left and right. So does it make sense, Uday? But you cancelled 0. So no, we cancelled it in the sense ki what we are doing, that left won't iterate here, left won't, if we are doing the next time, so the next time left won't go from that side, not I will increment. Obviously I will take one by one, I will increment, I will be iterating from here to here to here, then here, then here. So we are not cancelling it. This loop will work from n minus 2 for time complexity of n minus 2, and then we are playing around with left and right. Okay, we have to find the triplet. So one has been taken care by I, then left, and then right. So based on left and right, we will move around it. Okay, does it make sense? Okay, cool. So now what we are doing, so if you see, we have merge sort, quick sort. Okay, so basically when this is a primitive data type, or there is an integer associated with it, or primitive data types, like for example right now we have an integer array, so at that time quick sort will be applied. And if we have some kind of a object here in place of here, in place of primitive data type, we have some object. At that time there is the thing called tim sort. Tim sort will be what you don't know, right? We don't know what a tim sort is. Basically it is insertion sort plus merge sort. And obviously this tim sort is it takes a little bit more time than what quick sort. Okay, cool guys. So this is good to know information. So obviously you can just search it around. So people, there has been articles, we have many things, right? So people have done research and they have exhausted 2 days, 3 days. But if you are smart enough, you can just use this thing. Okay, right? So you can just go through these articles, right? It's good to know information. Okay, so when we are dealing with objects, okay, when it's a primitive data type, then at that time we will use quick sort. It internally uses quick sort. Okay, so now this approach is clear, right guys? But the interviewer is saying, okay, this is can we also do 5 plus 4 plus 1? So why are we keeping I constant at one position? Single and dual pivot, right? So yeah, basically Muyuk, at that time when the quick sort is applied, it does a randomized. Basically there won't be a pivot element, won't be there. I mean to say, it will not fix that it will be at the last or it will be at the end. It will be a random pivot will be there. Okay, randomized pivot. Okay, so Uday says, Abhishek, but in CPP which sort used there? You need to check that, Abhishek. Okay, you need to check that. I am talking about Java. Okay, arrays.sort, the class, that arrays class is there, and then the sort function. You need to check for CPP. It depends, right? You know that from language to language it depends which internally what we are using. Okay, cool Abhishek. Now Uday says, sir, why we are keeping I as a constant? Okay, so basically we are not keeping I as a constant if you focus carefully. Okay, so now listen, we have this 0 2 5. Okay, now let's sort it as 0 1 2 4 5 5 5. So there we have a for loop we have an outer for loop which is I. Okay, so I is currently here. Okay, and for the other 2 pointers, earlier we were doing with what we were applying, we were applying 2 for loops, one for j and one for k. Right now obviously that j was running from here to here, and then k was running from here to here, right? So if you see, most of these numbers were repeated. Okay, and all we need to know, if there is a pair, right? Let's forget about I. If there is a pair which will help us to find a triplet, so obviously it will include this, either this or this. So what we did, we smartly applied what we smartly vector is there in CPP. It is I think more faster. Yeah, maybe. Yeah, so actually it's better to use Java of inbuilt array functions. Yes. It depends. Obviously it depends from interviewer to interviewer, right? So if you are using arrays.sort on some primitive data types, at that time it's easy for you to sort that using arrays.sort, and you know that it will use quick sort in internally, right? So now this left pointer we have smartly used this left and right, and now we are just using these three. Earlier in earlier approach, this left was j and right was k. So now we have used smartly this. Okay, we have smartly used these things and we have found out. Okay, obviously if the sum is less, then then we will move around this thing. Okay, we will not focus on this part. Okay, we will focus on this part. And if we are having something that is greater than, we will not focus on this part. That I'm not cancelling anything, I'm just moving my pointer from right to here. Okay, so makes sense. You just focus on it, do a dry run, it will be easy for you. Okay, now the interviewer was, I mean to say, he was very strict, and he said, no Faizan, we don't want to do this thing in two phases, right? So this is the first phase and this is the second phase, right? This, what do you mean by phases? So obviously there will be some for condition, and let's suppose we are using we are using what, binary sort, I mean to say bubble sort. Okay, for that we need to loop around 2 times, right? So obviously this will be one iteration, that one phase we are doing, right, for arrays.sort, and then we are again using the second phase to find the element. Now the interviewer said, Faizan, I don't want you to use I don't want you to implement any I mean to say, I don't want you to use what, two phases. I want you to use I want you to do this thing in a single phase, and maybe you can use some extra memory. I thought, okay, let's think about the solution. Okay, now if you see what we have done in the third approach, okay, obviously that we are using, what we are using, we are having a space complexity big O of n. Now how do we do this thing? Okay, how do we do this thing in a single loop? Okay, if you see, in a single phase. Okay, this is only in one phase. Okay, right guys? So he said to me, okay, it's for loop. Yes. So now if you see, now again we haven't sorted it anything, we haven't sorted it. So what we will be having our array to, okay, 1 minute, we will just repeat this array, what we are having, this array elements. Okay, we have 0 2, and then we have 5, okay, sorry, 0 2 5, then we have 4, then we have 5 1 5. Okay, so now he said to me, okay Faizan, do it in a single phase. I said, okay. I thought to myself, okay, so now listen to me carefully, how smartly we used this thing. Okay, so obviously we know this thing, right? X plus y plus z is equal to k, right? This is the sum, and these are the 3 triplets. Okay, the 3 elements, right? So if I did something, if I do this thing, x plus z is equal to k minus x, does it make any sense? Obviously I just moved this thing to here, right? So now what I did, I smartly looked for this z. How? I smartly looked for this z by using this thing. I did what, x minus, sir, can you explain the code once? Which one, the earlier approach or this approach that we are having, that we are doing here? So let me just finish this thing first. Okay, so what we are doing, so I'm just smartly looking for, what does this look, if I'm doing this thing, right, k minus x minus y, I'm smartly looking for what, z. And if that z is not present, that means that this y, okay, third one, yeah, I will use it, I will explain it. Okay, that I'm smartly finding z, and I'm looking for z based on y, and if that is not present, I will store this y. That's what I'm doing. So now let's loop around it. Okay, so now we have this array. Now let's see. So we have created a hash set which is empty, obviously. Okay, now why we are using this hash set, you will get to know. Okay, so this thing is clear, and obviously it is iterating from n times, and inside we are iterating again. So the time complexity will be order of n square, that is clear. And the space that we are using for hash set, in worst case we can store all the elements in the hash set, and the space complexity is order of n. These two things are clear. So this thing is clear, this thing is clear, this thing is clear, right? Now we are using hash set. So now what I did, if you see, I'm using sum equal to k minus arr of I. So obviously if my sum is 10, right, in my case, right, my sum was 10, I am subtracting this arr of I from it. So that, why I'm doing this thing, so that I can reduce my time complexity. Obviously I can just, obviously if that thing is present in the triplet, then that the same thing that I did here, right? If you focus carefully, the same thing that I did here, I just moved this thing to here, and that what I'm doing, k minus x, this x is here arr of I and nothing else. So I'm subtracting the 0 from 10. That means right now we have 10. Sum of ARR of I. Okay, now this thing. Now what I'm looking, as I told you earlier, I was smartly looking for Z. That's what I'm doing in here. So obviously my I is here, right? My J is pointing here. Okay. Now what I'm doing, I'm smartly looking for this, the other element. Okay. So that's what I'm doing here, obviously. Now this sum is nothing but, what is sum? Sum is nothing but ARR of I, K minus ARR of I, right? At starting here, if you focus on this point. This was the sum. Now what I'm doing, I'm smartly doing this thing that I told you earlier. What? K minus ARR of I minus ARR of J. What does this thing does? This thing, what does it do? It smartly looks for K or Z, right? That's what I'm doing. If that K is already present in my hash set, right? If that K is already present in my hash set, that means I have found the pair. I have found the triplet, right? Makes sense? How smartly we use this expression. That's why I was going for the expression first. Okay. Okay. This is how I use this hash set. Okay. So now if that thing is present in my hash set, obviously we will have the pair and we'll return. Else what we are doing, we are just focusing on this Y because this Y hasn't been I mean to say this Y wasn't affected. So this might be, there might be the case, right? In case of 10, there might be the case, for example, right now my J is here. Okay. My J is on 5. So I found out, okay. So when I'm here, when I'm somewhere here, right? So I found out, okay, this 5 has not a pair, right? When I'm looking for this pair. So obviously this is 6 and 6 is not equal to 10. So obviously this 5 won't, where are the values in the set? Okay, now here are the values in the set. Okay, so the set has been added. So now if that Z is not present in, if I'm looking for that Z and it's not present in the, obviously for the first iteration, there won't be any element in the hash set, right guys? So obviously when I'm not having, when I'm not able to find anything in the hash set, what I will do, I will smartly put this value of Y in my hash set. So this Y will be present in my hash set. Right now in my case, let's do a dry run, more, that will be much clear. Okay. Okay, 1 minute. So let me just erase this thing. Okay, 1 minute guys. So let me just show you how this thing works, how smartly we are going to use this thing. Okay, this is very, I mean to say, this becomes the base of a lot of questions, almost 15 to 20 questions. So just focus on this question. It is very important for you guys to focus on this question. Okay, so we have 0 2, what were the elements? Okay, 0 2 5 4 5 1 5, 0 2 5 4 5 1 5. Okay, now we are looking for a sum of 10. So earlier my hash set is empty, right? My I pointer is here and my J pointer will start from here. Okay, that's what we are doing here, right guys? So these two loops, and then what we are doing, we are having a sum variable. We know how a sum comes into picture, that we are doing just nothing but K minus ARR of I. That's it. So ARR of 5 is 0. That means we are doing 10 minus 0. So that means we are still having 10 because the first element is 0. Okay. Now what we are doing, we are just removing this thing from the then what we are, once we are inside the another loop, that is the J loop, right? So the for loop that J pointer is responsible for, then what we are doing, we are just subtracting this sum and we are subtracting ARR of J from it. And once we are doing this, we are looking for a 8 if 8 is present in the hash set. Now what does this mean? If 8 is present in the hash set, this means that we have a triplet. So if we are not having a triplet, obviously that means this 2 might come into picture. So that's why we are focusing on this 2 and we placed our 2 in our hash map, in our hash set. Okay, done. Okay, now our J pointer moves here. So obviously the same thing happens. Now what we are doing subtracting 10 minus 5, and that means 5. We are looking for the element in the hash map. No, 5 is not present in the hash set. So we are placing 5 in our, this element 5 in our hash set. So same thing happens for 4. So it looks for, okay. So now let's see when we will be able to find a pair. So obviously now our hash, again our 10, that is 10 minus what? 4. And we are looking for 6 in our hash set. No, 6 is not present. So 4 will go again here. Okay. So similarly for 5. Okay. Now when when 5 comes into picture, that means that 10 minus 5 is having a value of 5. This 5 is present in the hash set. That means we have found our triplet. And now what will be our triplet? Obviously it will be the currently we are at 0th location, right? That I loop is on 0, right? We are that we have fixed our I loop, right guys? So I is 0. That means our first element is, okay, 1 minute, our first element is 0 in our triplet, and the second element is, now what we did, we were on what, this, our j was here, so j is our second element, so j is 5 is our second element, and the element that we have found after subtracting, that is 5, that is our third element, that is what, sum of ARR of I, that is minus j. So we have a triplet, what, 0, 5 and 5. This is the triplet, right? So which comes up, which if we add sums up to 10. So if that is the case, then we return true. Simple, right guys? Abhishek got it? Everyone, just give me a quick yes. This becomes the base for a lot of questions. So you need to focus on this question. Quickly guys, just give me a yes, no, maybe. Quickly guys, is this approach clear now? I'm not seeing any answers. Quickly, Abhishek. Got it, sir. Great, Subramaniam. Subramaniam, yes, great. Quickly, others, Afreen, Muyuk, Abdullah. Great, okay, great, Uday. Prakash says no. Okay, Prakash, just do a dry run on it. Okay, if you're not getting anything, that means you lack intuition, maybe, and that won't be able to you won't be able to focus on any other question if you're not able to what, dry run it, you need to do a dry run. Okay, you need to think intuitively. Okay, if you understand this thing, then there is nothing stopping you from understanding this. Okay, so if you understood what I did here, okay, we looked for k, we subtracted this thing, that is simple mathematics that we did. Okay, then we smartly looked for this z, that is the main thing, how we smartly looked for this z. Okay, so actually we are not so familiar with the vector functions. I haven't used any vector functions. Okay, I've just used hash set, and we're dealing with okay, if you are having any language problems, okay, if you're having language specific problems, you just go through any of the language that you are comfortable in, maybe C++. I won't suggest C because there will be a lot of restrictions on C. And if you're familiar with C++, right, that is the basic language we study when we are in college or when we are in our bachelor's, right? So you just go through C++ or maybe Java and start doing this thing. Okay, just there are a lot of sources available, right? We have in Great Learning, we have courses available on Java, Python, C++. Okay, that will give you a basic intuition, and rest is up to you. Okay, how you clearly, sir, what about 5 plus 4 plus 1 condition? Where is that 5 plus 4 plus 1? Uday, in the first question, in the first approach that you're talking about, 5 plus 4 plus 1. Okay, so that is simple, right? So you need to do this thing. Okay, so how can we implement it? What Uday, you are not being specific enough. Okay, how can we implement it? 5 plus 1 plus 4 plus condition. So basically, Uday, don't think, okay, I got your point. Okay, I got your point. What do you mean by 5 plus 4 plus 1? You're thinking of these at individual elements. Okay, so okay, got it. So you're thinking these elements that you're strict. Okay, you are not thinking out of the box. Okay, that's the problem here. So you're not thinking out of the box, you are thinking that we need to find these three elements. Okay, so what if I told you this means the same thing, right? This 5 plus 4 plus 1 is this same thing as 5 plus 4 plus sum minus 1? Is this the same thing? Is this the same thing? Is this the same thing, Uday? So we are just smartly using this thing so that our question boils down to a pair, not a triplet, but a pair. Okay, we are finding a pair who's having sum equal to this, excluding this one. So obviously now our new sum will be this thing, sum dash. Let's suppose this is sum dash. Okay, or someone. Okay, so we are smartly boiling down. That's how you reduce your time complexity, by thinking out of the box. Don't be strict. Okay, don't think within the box that okay, we are saying the three elements and we have to just loop around three times and each time we will get this. Think out of the box. This, when I did something that, oh, I shifted this one on the other side, I reduced my question to two pointers, right? No sir. Okay, okay, just give it a thought. Okay, so let's not focus on this question right now. So, and I mean to say, not focus on this question, let's not utilize any more time on this question. You just go through the lecture, try to dry run, go through it again, maybe that will help you. Okay, okay Uday, great. So now let's see. Now if I told you the same question, now I want you guys to print the pair or print that triplet. So obviously we were earlier doing what, true and true false here, right? Now you just have to use a SOP statement, that is print statement. Okay, you just have to use print statement and then print all those elements, right? ARR of I, ARR of J, and ARR of and sum minus ARR of J. That's it, right guys? So this will give you the print and you will be printing all the elements. Okay, so why I used in a hash set, or why and not the array, so that there won't be any repetitions. Okay, okay Deepa. So we have a property associated with sets, right? And this contains operation takes constant amount of time. That is what is important, time complexity. Okay, okay Deepa. So that's why. Okay, so now if someone told you give me the pair, give me the triplet, any triplet that is having a sum equal to k, right? If someone asks you now what are the base questions, or what are the questions that are based on this, okay, now let's see. So find a triplet with sum equal to two elements equal to third. That means earlier what we were having, 0 plus 5 plus 5 equal to 10. Right now you just need to find a triplet whose sum is equal to, let's suppose you need to find a triplet that is, let's 1 2 3 is a triplet because 1 plus 2 is equal to 3. Okay, so you need to find a triplet whose with sum of two elements equal to the third. That sum of two elements is equal to the third, and all of these elements are present in the array. So this is also based on this question, right? Right now earlier with what we were having this condition, right? Sum equal to, now the sum is 0, let's suppose, and this question boils down to this thing, that x plus y is equivalent to what, z. And now obviously that is the thing that we were doing, right? So this question is based on this. Now you need to find a triplet with maximum sum. That's also the base question, is that same question that we were doing with minimum sum. Okay, triplet with sum equal to 0, right? X plus y plus z is equal to 0, right? Base question is same question that we did. Okay, yes, I plus j is equal to sum. Yeah. Okay, yeah, so yeah Abhishek, yeah. So I plus j is equal to sum, and that sum, what this x plus y equal to sum, this sum should be also present in the array. Okay, that's what this question is about. Okay, the triplet. Okay, great. So now, and what else you need to count if you want to count all the elements, all the triplets, right? These are all asked in Amazon, right guys? You see how easy is this thing if you know just one approach. Okay, max sum I j. Abhishek, yes, you can figure that out, right? Even if some of the platforms have given some better approaches, right? Then also you can use that thing. Okay, so you see, but the base question is that the parent question is same that we did earlier. Okay, that is the parent question. Now if you want to count all the triplets, right, all the triplets with sum 0 and all the basic variations, that is possible. Okay, now right now we are dealing with just integer numbers. Okay, so you can also have strings, right? You can also have words, right? You see the variety of questions that you will be able to solve. Okay, now it's around 20 to 25, but I'm just focusing on that 15 to 20 questions. Okay, so some of might have some might have a bit more variation. Okay, so now just you need to focus on this question, that is the base of all, and you just need to understand carefully what each approach does. Okay, how we use two pointers, how we use hash set. Okay, so you need to focus on all these things. Okay, so this is our 20 questions are done. Okay, so just by one question our 20 questions are more than 20, but I'm just restraining it to 15 or 15 to 20. Okay guys, just quickly give me a yes or no quickly, so that we can move to the next question, which is a bit more important than this. Okay, quickly give me a yes, no, maybe. Quickly, guys. Yes, no. I want a response from each one of you. And even if someone is not able to understand anything right now, more, I mean to say, more in depth, but give it a try. Solve questions. Okay, solve more and more questions, revise through all the questions that we did, use lead code or any other platform that you're comfortable with. Okay, you need to practice a lot, guys. There is nothing you can do. You cannot move along if you are not practicing. It is something that if you have studied today, it will be you will be you will be forgetting this thing tomorrow. Okay, you need to practice. Okay, great. So now we are done with our questions, almost 20 questions. Now let's see now how to solve a medium level problem. Okay, now what we are going to use, obviously it is based on arrays. Okay, we have arrays, we have hashing, and we have heaps. So now this forms a medium level problem. Okay, only if your hashing is clear, only then you can move to heaps. Okay, not heaps, then you will be able to solve this problem. Okay, now let's see what is the problem. So you need to find the top k frequent elements. This is very important question. This was asked in, again, Facebook, Amazon, Google. Okay, very important. Again, we will see how easily we will be able to solve this problem. Okay, now you need to find the top k frequent elements. What do you mean by this thing? And there are a lot of constraints with this question. Okay, that the constraint, one of the constraint is that you will always find a unique pairs. I mean to say, the frequent ones will be always unique. There will not be the case that 2 is having a frequency of 3 and 5 is also having a frequency of 3, and then you have to find the top, I mean to say, top one frequent element, or the top most frequent element. That is, then there will be a confusion, right? Should we go for 2? Should we go for 5? There will always be the case that if some of the if our answer will always be unique, right? So let me show you what does this question means. So if you just see this question, 2 2 5 4 5 1, so you see 2 is repeated twice, 5 is repeated thrice, and 1 is repeated once, and 4 is repeated once. Now you need to find the top two elements which is having frequency more. Okay, so if you see this problem, so 2 is having 2 and 5 is having 3, so our answer should be 5 or 5 and 2, because those two elements have the frequencies. That means they are occurring, okay, they are occurring, rest of the elements are occurring less than this. Okay, so 2 is occurring twice and 3 is occurring thrice, and we have the answer for top k elements or top frequent elements is 5 and 2. Okay, so now you might be thinking, okay sir, when if this is the case, then what should we do? Or if this is the case, right, so 2 is repeated thrice and then 4 is repeated twice, 5 is repeated twice, that won't be the case. That question is specifically constraint having. You can just go through on lead code and see the constraint as well. Okay, what are the constraints? Okay, so this is the top k frequent elements. And if you see this another question that is written here, so 1 is repeated thrice and 6 is repeated twice, 2 is repeated once, and -4 is repeated once. Okay, so you need to find the top k elements. That k is right now here is 1, so the top the most frequent element is the 1 is occurring more than thrice, and rest of the elements are not occurring, so our answer is 1. So you got the question right, guys? Quickly just give me a yes or no. So the question is clear, right? We have to find the top k frequent elements. Okay, so this k depends on what? So this k can be 2, this can be 3, right? So you need to find that thing. Quickly, guys, just give me a yes or no, so that we can move ahead with the solution. Okay, quickly, guys, I'm waiting. Chandrasekhar, Prakash, okay, great. Tanushri, Pramod, Satish, Moyuk, where is Abhishek, Afrain? Quickly, guys, just give me a yes or no. Okay, great. So now how would you do this thing? Okay, so now before moving to the solution, I told you, but for first question, Initial says, but for first question, the output is 2. No. The output is not 2. Therein we have to find the two such elements which are frequent. So which are occurring more than, I mean to say, who's having the frequency greater than rest of the elements. Okay, so 2 is having a frequency of 2, right, and 5 is having a frequency of 3. So these two are the elements. Okay, so it can be in any order, right? 2 5 or 5 2, it order doesn't matter, but we have to just print them. Okay, in the second element, the k, that is, if you see, 1 is repeated thrice, 2 is repeated once, and 6 is repeated twice. So top first element, or I mean to say the elements which are having frequency greater than rest of the elements. Now how many elements we are looking for? We are looking for one element, such one element. So in that case, 1 is the answer. Okay, so now let's go ahead. Okay, cool. Now let's see this thing. Okay, this is very important. When I told you guys to go through comparator, right? I told you go through comparator and comparable, go through them. Okay, so now I won't go into the knowledge of the, I mean to say, in language specific knowledge, but good to know information. Maybe rest you can do it on your own. Okay. So now if you have to do, I told you guys, when you use a priority queue and then you say heap, and then you use new again, then pk, that's a priority queue, and then that's it. So it always creates a min heap, right? We know in Java, when we use priority queue, it always creates a min heap, right? So what if you have to create a max heap? How do you do that? Okay, we use a comparator. Okay, now these are the three things, these are the three ways with which you can make this thing what? A max heap. I am a little bit old school, so I use this approach. Okay, so what I do, I use priority queue integer max heap, new priority max heap. That is the I mean to say, that is the thing that we use to declare a priority queue, and then we use comparator, and within that we compare these two elements based on what? We will just reverse the natural ordering. Okay, so now it will be a min heap. Now it will be a max heap. So if this approach is not clear, because there is having, this approach will have some overflow conditions. Okay, this is something good to know information. If you want to go in depth, you can just I mean to say, watch some video and language specific, right? It can change from language to language, so that's why I'm not focusing this much on this thing, but it's a good to know information that how you can create a max heap. So this priority queue int max heap new. So how you can create a max heap? There is another approach that we use, collections dot reverse order. Okay, this is one approach. And if you want to create it another way, then we use a lambda function. That is also called, if someone is familiar with arrow functions that we have, right? Also known as lambda functions, that arrow functions we have in JavaScript, right? So here we have used the approach of lambda functions, right? And another approach is, just to avoid this overflow condition, that y minus x, we use what? Y dot compare to x. Okay, so these are the three approaches. Now you might be thinking, okay sir, we know we have a good, I mean to say, we are a bit familiar with this thing, but what if I told you, when you have a primitive array, right? This array is of type integer, right? The primitive data type, and this is having these elements. I told you to do arrays dot sort, but I want this obviously when I sort this thing, it will be always in ascending order, right? So now it will be in ascending order, so that means we have 1 2 4 6 10. So this is the, when we use arrays dot sort. What if I want it to be in a descending order? That means 10 6 4 2 1. How can you do it? Is it possible to do collection dot reverse here? No, this will give you an error because it won't work on primitive data types. It works on objects. So that's why we have to use some another, that is the derivable class. So that is called integer. So that's how you change this thing to integer array, right? So rest won't be change. Then we will do this thing, and then you can apply this collection dot reverse order. Okay, so this is good to know information how you can create a max heap. Rest is up to you. You can just go through your own language in which what you are comfortable with, so you can just apply that thing. Okay, is it clear? So how you can create a max heap, or how you change the natural ordering using comparator. Okay, now let's move ahead with the question. Okay guys, so now how you can do this thing? Obviously, if you observe carefully, so now let's 2 2 5 4 5 1 5. Okay, now what we have, 2 2 5 4 1 4 5. Okay, let's remove this thing. Yes, 3 and 5. Let's do this thing. So obviously now we have to find the frequency. Whenever we are dealing with frequency, obviously the first approach that will come into your mind that, okay, I will create a map. Let's create a map. Okay. Now, once we have created a map will look like something this. 2 is appearing thrice, 4 is appearing once. Order doesn't matter. Obviously, it doesn't depend on this. When we create a hash map, ordering, it is not specific that you will have your 2 present first, then you have your 4 present in the second position. Ordering changes. Okay, we know that. So 2 is present twice, 5 is present thrice. Okay, 2 is present twice, 5 is present thrice, 4 is present once, 1 is present once, and 3 is present once. Okay, so this is the hash map what we created. Okay, done. This is the first approach that we can, that comes up into our mind. So now we know that we are looking for something that is, we need top k elements, and whenever we deal this top k elements thing, the first thing that comes up in our mind is heap. So obviously, if we store, somehow we store these elements in a heap, then let's suppose you stored 2 and then you stored 5. Now we are creating a max heap, so that means this parent will be max. So the root element will always be greater. Okay, so now once we created this max heap, let's suppose we created for these 3 elements. Okay, so which is the greatest? 4. Then the 2 things, that is, it can be either on this side or on this side, that doesn't matter, but this is specific. This we know for sure that this element will be greater, right? That's how the heap works. Okay, great. So now what, we know this thing for sure, so now we can build upon something on this. Okay, now let's see the approach. So the first thing that I told you, we will create a hash map. Done. This is the hash map that we created, right? Our hash map, this map that we created. Done. So this thing is done, right? I created an integer map with the key is here. What? The key is the array elements, and what is the value? Value is the frequency, right? How many times it occurs, right? Great, guys. So are you getting, are you following along this thing? How we created this map? Is it clear? We can use also get default that thing also, but again, I use this thing. So if that is not present, get that element, and if that is present in the element array, if that is present in our map, get the value of that and increment it by 1. If that is not, print 1. Put a 1 in that. Okay, so let's suppose 5 comes first time, so it won't be present. Yeah, great. So this is the map we created. Now I told you we have to create a max heap, so we created a max heap here. But now watch this carefully. So earlier what we were doing when we creating a max heap, we did this thing, right? So now let's forget about this thing. Let's keep it simple. Now here we are creating a max heap. Done. Now what else? So now we are creating a max heap. So how we insert our elements in our map, in our heap? So we are just fetching all the key sets. What are the key sets? Key set is nothing but the array elements. This is our key set, right? This is our key set. Or let's be specific, these are our key sets, right? We are inserting these elements in our heap. So we are adding, right? We are adding. So first we will add what? 2, then 4, and then 5. So we create a heap. So we add 2. Okay, now 2 will be inserted. Now when 5 comes, okay, now we are creating a max heap. But when we do this add function, we are creating a max heap, right? Now this function will be called, this priority queue, based on what we are building it. Is it a max heap or not? So we are doing what we are doing here. If you observe carefully this statement, we are fetching the value part of it. Okay, we are fetching the value part of it, and based on that we are sorting it. Okay, so based on that we are okay, so based on that we are using what? Based on the frequency. Now what I told you earlier, there is a slight difference between a max heap and a min heap. If you observe carefully, this thing that we have written here, map.get a minus b, map.get b, is it a max heap? Is this a max heap? Now the question is this: is this a max heap? If it would have been a max heap, then we would have done something y minus x or b minus a. So what we are doing, we are just changing our max heap. That is, we are changing our min heap. We are again implementing the min heap, but we are changing it and we are using the frequency. So the less frequent element will be present here because we are creating a min heap. So now what actually we do, so 2 will be inserted because there is only single element, right guys? So you have to be very careful. Listen to me, I will repeat it, but listen to me carefully. So 2 will be inserted, there is no such thing, right? So the frequency of this thing, what will be? It will be 2, right guys? This will be 2. The frequency of this is 2, right? So let me this small 2 represents its frequency. Okay, now next time when 4 comes, okay, so now 4 comes, obviously now the order will change, right? Now 4 comes, 4 will come up and 2 will go down because we are creating a min heap based on its frequency. Its frequency is 1 and its frequency is 2. So based on the frequency, this 4 will go up. Okay, now when 4 is inserted, when 5 is inserted, 5 is having a frequency of 3. So obviously 5 will come either on this side or on that side. It doesn't matter. 5 will come here as its frequency is 3. The small 3 represents its frequency. And now once we build this thing, now okay, now listen to me carefully. Now this thing is clear. Based on we created a min heap based on its frequency. Okay, so that's why 4 is present on here. Okay, 4 is present here, not here. Okay, because if you might think that okay, 2 is less element, 2 is smaller than 4, why not 4 is present at the top? Because we are creating a min heap based on its frequency, right? So now if you see, that's what we are doing. We are getting its value, right? We are getting its value, that is frequency. We are getting its frequency and we are subtracting it, maybe this a minus b. So this all is dependent on this priority queue or the comparator that we are building. Okay, that's it. Okay, so now you think that obviously, okay, whenever we use comparator, we are creating a Maxip. That's why I told you, okay, let's forget about this. We are creating a Maxip. No, we are not creating a Maxip. We are creating a min heap, but with some kind of a, some changes, with some changes. Okay, we are not using it store the value or the key. We are storing its frequencies. And now you might be thinking, okay sir, then why are not we creating this frequency table here like this 1, 2 and 3, which represents the frequency of all these elements? If you observe carefully, we are adding n into our map, not. And what is n? N is the key set, and key sets are array elements. Okay, key sets are array elements. That's it. So that's why what we created is here. Okay, and now we know internally, okay, we are doing it based on the frequencies. Okay, now what does this statement do? What does this statement do? Okay, now this k, that means we want to deal with only k elements. That means top k elements. That, for example, let's suppose right now we need two elements in the array which are most frequent. Okay, so at that time we will get, what we will do, we will just, now this k is greater than, obviously when we inserted 2 elements, this k should have been smaller, right? Less than 2. Now it's greater than 2. So now what we will do, we will always fix this to 2. There will be always 2 elements present in our heap. So now once we will remove the top element, obviously that won't be useful to us, right? So obviously when we remove this thing, this won't be useful because it's having less frequency. We are dealing with something, the question says top k frequent elements and the frequency should be higher, right guys? So great. So now obviously when we remove it, it won't be in our answer. So now what we have 2 here and we have something 5 here. Okay, right? So does it make any sense? So this will be our heap. So every time we are restraining our heap and we are storing only 2 elements in our heap. So that's what we did here. And obviously when we remove something, that would be less than, that will be having lesser frequency, right? Right, great. So now after that, once we have once we have looped around all the key set, that means all the elements present in our map, then we will be having at the end we will be having only 2 elements, and which will be the most frequent ones, right? and when we pull those things out, then obviously we will get, if we are building in such a manner, we will get 2 first and then 5, because 2 is having frequency of 2 and 5 is having frequency of 3. Obviously the lesser element will be present at the top, so this will be the element that is fetched out first and then 5. Okay, does it make any sense? Just quickly give me a yes or no. This is very important question, and you will be, I mean to say, I'm for sure, if some of you, or once you will be facing interviews, each and every one will have one such question that he will be facing anytime soon. Okay, so this question is very important and it is very simple. We will talk about the space and time complexity of this approach, but is this thing, each and everything clear? Except from the language dependency part, that is the comparator. But I told you how do we implement this thing. Now you do your research on how does it work. Okay, great. Quickly, Abhishek. What? Okay, sorry. So Abhishek and where are the other guys? Abhishek, Anil, Deepa, Arjun, Amit, SP, Mayuk, Inshal, Afreen, Deepa. Quickly, guys, quickly. Clear. Great, great, awesome, awesome. So now let's see. Now let's see let's see the space complexity first. So obviously we are storing elements in a hash map, and we can store all the elements in the hash map. Is this thing clear? This ON. So obviously hash map, we are doing this hash map, right? Fourth has been discarded. Fourth, what? Yeah, what fourth, Kunta? What fourth has been discarded? Okay, so now obviously, and we are storing only k elements, right? If the k is 2, only 2 elements will be stored. If k is 3, only top 3 elements will be stored, right? Right? So obviously we are storing for priority queue, we are using a space of big O of k, right? And therefore the total time space complexity is what? This is the space complexity, right? So is the space complexity clear? Quickly, guys. Yes, no, maybe. Quickly. Quickly, guys. Is the space complexity clear? Great. So now just go through this and see. Here we are just using this extra space. Here we are using this, I mean to say, when we are creating this, here is the big O of k space, and here is the big O of n space. Okay, now what is the time complexity? The most important thing. Okay, the time complexity part. Okay, so now for building a hash map, we are iterating through all the elements in the array, right, guys? So the time complexity will be order of n at that point, right? So in this point, this is important, very important. So at this point, we are iterating through all the elements, right? Here if you can see this for loop, we are iterating through all the elements. So the time complexity will be order of n. Is it clear, right? So let's forget it about for now. Now, when we are removing the elements at the end, what will be the time complexity? Here, when we are removing all elements at the end, the time complexity will be what? We are doing this operation k times, and every time when we remove an element from heap, it will take log k time. So this is the thing. This for removing the elements, the time complexity will be this. Now what about this part? For the first k elements, if we talk about if we are not removing anything from the heap, then it will take order of k time, obviously. Now in the worst case, when we need to remove each and every element for every operation, for the first 3 operation or first k operation, it will be k log k. Does it make sense? Right? For this part, right? For this part, let's suppose each time the part that I'm removing. Okay, I just made it worse. Okay, just a minute. Okay, cool. So now let's see. For this part, if we are doing this operation in the average case, for 3 operation we don't need to remove anything, right? But in the worst case, if we need to remove every time, that means we are taking k log k times, right? Does it make any sense? Okay, so now what happens, this operation will, for the first k elements, and for the rest we are doing n minus k log k. Obviously, this k will be removed from this, and for removing or adding the elements, we take log k time and n minus k. Now, when we add up both these things, right, the k log k and we add up this thing, that means we are doing this in multiplication, right, n minus k log k. When we add up these two things, we will get a time complexity of n log k, right? So it will be something, right, n into k log k and minus then it will be k log k, right? Something, it will be a constant term that will be removed, and something we will get like this. So n into n log k. So this will be for the this part, okay, and this will be for the this part, okay, the second part. So for here we have time complexity of n log k because we are doing operation for all the elements in the worst case, and for here we have k log k, right? And for here what we have a time complexity of big O of n. So now when we add up all these time complexities, we will get a time complexity that is of order n log k, not n log n. And obviously n log k is lesser than n log n. Cool? Cool, guys? So that is a question. Just go through it. Go through the time complexity once again. Go through, revise this session. This session is very important, and you will face a lot of problem in these questions. But time complexity and space complexity, you have to be absolutely sure. And now let me give you an intuition on the other problem. That is, we are using the same approach that we used earlier. Okay. So now we have a frequency sort problem. In this, we have given a tree, and you need to sort on based on frequency. So E is having 2 frequency, T is having 1, and R is having 1. It can be either this or it can be either EERT. Both these solutions are accepted. Okay, so this is the question that we are sorting based on the frequency. Now same thing we are doing. So obviously we are having string, so we need to first convert the string into a character array. That's what we are doing here. Then we are creating a map. Same thing, hash map, what we did earlier. Hash map was created. Okay, then we created a sorry. Then we created a priority queue based on the frequency. That's what we did in the earlier question, right? Same thing, based on the frequency. And now here, if you see, we are not using a comparator, we are using a lambda function. That's what I told you, right? So one of the 3 approaches with which you can create this thing, okay? Right? So this was the thing, and you can either iterate, or you can also do this thing. You can add all the elements just like this thing, just like this, add all map.keyset in your map. So every element will be added in the hash map, right? So after that, what we did, we built a string builder. Why not string? Because strings are immutable, okay? So that's why we use string builder, and then we appended our answer. So obviously when now we are creating what Maxip, right? If you see, we are creating a Maxip b minus a. We are creating a Maxip. So Maxip based on frequency. Okay. So obviously the top element will be having a frequency. Let's suppose we have a tree, and this tree is having E. So E will be here with frequency 2. So now once we remove this thing, right, our hash map won't be empty. Now once we remove this thing, we added this thing in C. Now obviously this E is twice, so we need to append twice it in our output string builder. So that's why we use this loop. We added it twice and appended it. So EE will be in our string, that is string builder out, EE will be there. And then what we did, once we iterated it, and then we removed this element. Done. Now either T or R will be up, right? We don't know that. That's why both the answers are valid. EETR and EERT. Both these answers are valid. So that's why if we get a T, then we found out its frequency, and then we inserted it in our hash map, in our output string. Done. And then we returned the string, the final string. Okay, go through this thing, and obviously you need to find, I'm letting this up to you. So you need to find out, just put it on a comment section, what will be the time complexity and space complexity of this frequency sort. Just put it in the comments, figure it out, put it in the comments, what is the time complexity and space complexity of this problem. So I have told you earlier this thing. Go through this session again. This is very important session. You see, we use the same thing, and this is a medium level problem. asked in Amazon. What is the parent question? This is the parent question. And now what you can figure out how important these questions are. I'm not using any question. Yeah, strings are immutable. Yes. So we need to reassign them. Rather than doing that, I use the string builder so that we can use the append function in that. Okay. So will we, yes, there will be. We are just starting. We are just getting started with competitive programming. This is nothing, but the level of this, see, the level of this questions or the questions that we do is very important. That we are doing all the questions that are asked in big tech giants like Amazon, Facebook, Google. So we are doing only those questions, so that the rest of the companies which are not that much, which do not pay that much, will fall under it. Okay, we are aiming for the stars. Okay, we are aiming for the moon, and if we don't reach there, at least we will fall somewhere in a good position, right? So that's what we are focusing on. Even if you're not getting these things, focus on this. Do not mug it up. Do not do, I mean, say, okay, when we get this question we will do this. The question varies. There is a lot of variation between these questions. You just need to focus on that question and what you think of it and apply it. Okay, don't mug it up. Okay, it's not something that you can remember. It's just that you need to understand this. Use Try to practice a lot. Okay, this the practice is most important in these kind of questions. Okay, or when we talk about CP or computer programming, you need to practice a lot. It's not just that you can mug it up or you can just remember things. No. Okay. Okay, thanks a lot, guys. Now you just put a comment once you are done with this session, once you have implemented it, once you had implemented this frequency sort, put it in the comments, the time and space complexity. Okay. Okay, guys, and the new ones who have already left, or some of you are new, go through all the series. This is a 7 part. Go through all the, there is almost 6 more sessions. Obviously there are 6 more sessions, so go through them, apply it, implement it, use lead code, use geeks for geeks, whatever you feel comfortable in, and implement these things. Okay, cool, guys, thank you so much. Okay, I hope, yeah. So, will there be a next session? Yes, yes, Pramod, there will be. Yes, there will be a next session on maybe next Saturday or Sunday. Okay, so it will be always on weekends. Okay, great, Satish. Great. So, thank you so much, guys. Thank you, Abhishek. Thank you, Arjun. Okay, guys, you need to implement these questions. Okay, this is not something that you want to forget. Okay, these are very important questions. All the questions that we have done so far sorry, are all important questions, and these are asked multiple number of times. Okay, so thank you so much, guys. Great. So I'm just concluding this session. Thank you so much, guys. Thanks a lot.